Okay, Bismillah. Now, just to refresh what we have covered so far in this chapter, we've covered moment about point, and we could do FD and F. We also covered moment about an axis and also we have covered moment of so this is what we have covered so far, and we have covered several examples for couple or conflicting moment of couples, and today we'll continue with another example. Alright, so here in this case we have just a couple left. We have two forces in the opposite direction acting at the location shown. And we have F going upwards, is basically 80k, and then this is the negative 80k going downward. Find the couple moment acting on the part assembly using Cartesian vector notation. Alright, so what do we do? First, is the question clear? What should we calculate? So, of course, this is again straight away application of the equation, right? So we know there's a couple where you have two forces there. So with M equal to R cos F. The question is, okay, which one? Okay, if we'll say, because we have two options, right? Either from this force to this force or the other way around. Let's say we'll take this F as this one, which is, if F is 80k, positive 80k, right? What will R be? $200I. Is it?
200I.
Plus 800J. What are you calculating right now?
Plus 0k.
So it's like this.
800 change to 300. Yes.
This one is 300.
Yes.
So 200 plus 300 plus 0. 600. Here 600. 500 plus. Which one? Okay, which R are you taking? How do you? Okay, the R should be from where to where?
From the point at the
From this one to this one?
yeah.
Like this? No, like this?
The green part.
Green. Okay, ni?
No.
What's that? Okay, the concept is R is from where to where?
Green couple.
If you have two forces like this, if you use R in this one, F will be this one, right? And vice versa. So in this case, 500. Which one? For X component is
0.
S component 300. 100.
Zero.
0.
Some say zero, some say 100. 100.
100.
Do you get this?
Minus.
Okay, of course. As we mentioned in the previous example, if you cannot detect straight away or you tend to make mistake, then might as well just make the coordinate first. Right? What is the coordinate here? 200, 300, 0. And then this one? 800, 800, 0. So which one minus which one? On the right minus on the left or? So this minus term become 100 and
500.
plus 500 G plus 0 G, right? So it should be straightforward. The only thing is if you tend to, because sometimes visually it can be deceiving in terms of if you do not take note of the number there, right? So might as well just take the coordinate and then you minus. Right? Normally when we calculate the coordinate, we tend to make less mistake. So if you have this one, then it's just plug in the matrix I, J, K, then this one 100, 500, 0, and then 0, 0, 80. This one should be very straightforward, right? Okay, so this one I will be
5,000.
is it 4,000? 40,000 minus 0, is it?
Yes.
Is it? On J, we have 8,000 0 plus K 0 minus 0, right? Alright, so it should be like that. So of course this question is quite short because we only have one couple to deal with. So in this example also we have meaning the slide is using the same R and F, and then you get that value there. Of course, if we have to write the unit, right? In this case, it will be what unit? What we did just now. This will be Newton millimeter, right? So it will be in terms of 40,000, 8,000. But if you have in terms of the slides, if they use in terms of Newton meter, then it will be this form. As long as you state your unit clearly, then it should be okay. If you miss out on the unit, as you may see from the quiz that will be written after this, you will lose some marks there. Alright, any question? Now we have covered, I think in the previous class we have already covered several examples already. So if you have multiple couples, then we just have to identify each one and then get the summation of the effect. So I think that was the end. Okay, a couple is applied to the beam as shown. So can you compute the moment? Can you calculate this on your in your head, or is it straightforward or not? What do you get? Of course, if you cannot imagine in your head, you can try on a piece of paper. So what do you get?
80.
80.
No. 60.
60.
That's 60. No idea. Kalau that's 60.
Any other answer? How many have you get 60? Tak berani lah. Okay, is this difficult? What do you do? Okay, normally step by step, what do you do? If you can visualize, if you make the XY component, you will get two pair of forces, right? You will get one in this form, and another one will be like this, right?
Yes.
Obviously, this cancel each other, where you have 40 and 40, right? And then this one, what is the force here? Okay, do you have any problem to get this 40 and this 30?
No.
From this triangle?
No.
And then what is the distance? 2, right? So you get 60. So I think for those who have done some exercises, it will be quite easy to get that one. Okay, what about this one? This is just, but this is quite difficult to see. Okay, let me just make it more clear. This is A, this is B, this force is like this, minus F, this force O is like that, F, E, F, E. So it says that if F is minus 20k, R will be which one? R? BA. Why?
Because
Like this, you say, right? Because the force is taking this one, right? So it should be R from here to here, and then F this one, right? So this is just to see whether you are basically paying attention in class. Right? Attention please. So make sure you understand all of this. Any question? Anyone do not follow or do not understand anything?
Can't be RAB.
RAB. No, because the question says if we take F is minus 20k, meaning obviously F is this one. Right? So by definition, you cannot take here to here, right? Because of the concept that we use in terms of the equation. If you want to take RAB, then you have to take F equal to positive 20k. Basically, that is what it means. Alright, so that is the end of couple. So we'll move straight into the next component that we have to cover, which is simplification of force and couple system and their further simplification, right? So in this part, we'll have to deal with simplification. Although what we are doing is to simplify, but to do it to do actually the process, hopefully it's also simple. Now, in reality, okay, this is related to what we have before that. Now, in terms of application, because this relates to in terms of application, if you have to design something, right? If you have a structure like this, we have many force, moment, etc. applied, and we need to design the support here, and we need to know what is the support, what type of load and what type of reaction that we need to have at the support. If we have in this format, it's quite complicated to solve for that one, right? So we want to have. Is it possible to simplify many different forces to just become one force and one moment at that particular point? So then we know, okay, then the point here have to just sustain this level of force and this level of rotation, right? So that's the intention. Right, so when we say simplification, what we mean is from a system where we have no matter how many force, how many moments, we want to have just one force and one moment at any particular point. So that is the idea. Do you understand the idea first and foremost? So we want to have that, meaning you have multiple force, multiple moment, we just want to simplify at this particular point. Normally that particular point is given by the question. What is the force, equivalent force and equivalent moment, right? Now, we'll do this first in terms of the mathematical visualization, right? If we have, like, let's see, this is just to redraw, same thing, right? If we have a beam, say, beam, and we have a force, I think, at this point in this direction, with this magnitude, can I add something like this? Where I add two forces here at this point, have I changed anything? To the meaning, is the effect to the beam changed in any way? No, right, because basically, if this force cancel each other, and it's basically you just add two forces that cancel each other, meaning it's like you don't do actually anything, right? Now, the next question is, can I cancel this and this? Does it cancel each other? Yeah, there's this force with this same F to the right, and this force to the left cancel each other. So can I just erase it?
Yes.
Okay, if you say yes, then fundamentally this will be just the same as this one. Meaning the effect to the beam, either the force is here or the force is here, is the same. Boleh tengok tak? If the force is the same magnitude. Meaning if someone is pulling you in this direction with the same force, or someone is pushing in the same direction, the effect to the body is the same. Can you check that one? Alright. That is in that case, right? What happens if what I have is something like this, for example, F here. So let's just to redraw the same thing. Okay, so can I add this to force?
Yes.
Yes.
This is basically same as adding 0, right? Because it's simply cancel each other, right? Now, can I cancel this? Does it cancel each other?
No.
Why not?
Yes.
So I can cancel?
Yes.
Can I erase this?
Yes.
Ada ni like. So what's the problem with this? Not the problem. What do you notice from what we have learned? Yeah. What is this? Do you notice that this is a couple?
Yes.
By definition, because it's parallel, opposite, the same magnitude, right? So when a couple, the effect in terms of force is because just now it's basically just cancel each other straight away, right? But in this case, it do not have only the force that you have to consider. When you have a couple, you have the rotation, right? In this case, the rotation is counterclockwise, right? In this case. So if you want to erase this, you have to replace with the same effect, right? Yeah. So if you want to erase this, then you have something like this, which is calculated from m equal to Fd. So just now, the force and the distance, right? So meaning in this case, this will be equivalent to this one. From the step by step, if we do what we have done, because we didn't change anything from the beginning, right? We just, okay, we added two force which is equal to 0, we do not change anything. We just replace this with a equivalent moment which the same effect, right? So in this case, the effect of this force is actually equivalent to the effect of this force and this moment, because the distance actually produces that rotation, right? At this point, so that's how it becomes like this. So this is the Okay, so you'll see. Okay, this example is quite similar, but it's the opposite direction. So you get clockwise because the couple is clockwise, right? So this is the basic concept that you have to understand to apply what we will be learning in this subject. So are you still following, or do you understand what's going on? Why do we need to do this? Because from the beginning when we say what we want to do in simplification is we want to bring everything to the same point. So that's why we don't want the forces in this position anymore. We want it here, right? So you cannot just simply bring it here because the effect is not the same. Because basically you have the couple just now, so you have to replace this one, right? So hopefully you understand, because it will help you to understand why we calculate in such a way. Alright, so basically, if you understand that concept, so originally, for example, in this 3D object, we have one force here, and one moment here, for example. Now, this moment is couple moment. You can just simply bring it to any point that we want, and it doesn't change anything. First and foremost, do you understand that? If you understand the example that we showed before, when the couple we bring anywhere, the effect is the same, right? So it doesn't change anything. But when we want to bring this F1 to this point, to this F1, we cannot just simply bring, because the position there is actually also have the couple effect. So that's why when we want to bring F1 here, you have F1 and then R1 cross F1 from this R cross F. So when we want to bring F2, you bring it here, and then you have also R2 cross F2, meaning the shifting also produces the moment. So in the end, you have all the force and moment at that particular point, and then you can just find the resultant, meaning in this case F1 and F2 becomes FR, M becomes this M resultant, right? So basically that's the idea of steps that we do. We shift everything to the point that we want, and then you get the summation there. So in terms of the idea, do you understand what's going on?
Yeah.
Alright. So in the end, in terms of the calculation, it's just simply because this M and this F is in vector form is exactly the same, right? It's just the position is different. But if you want to calculate the force, it's simply in the end FR equal to summation of F, right? So that's simple. But here is where you have to understand, where we want to get what is the resultant moment in the end. Here it separates. MC is couple moment from couple. So it's just summation of any couple moment there. If you have multiple, just add, and then summation of MO is basically R cross F. This is moment about point O. Why O? Because in the end we want everything at point O, and the distance from O, right? So yeah. So in terms of equation, you can just memorize this one, but if you understand it, helps in terms of applying this equation. Alright, so for example here, if you have these two weight from the traffic light there, W1 and W2, and the distance of D1 and D2. So if you want to shift here into just one force and one moment, that this WR becomes what? No, the W, the weight, the force. So you just add these two, right?
Yes.
What about this M moment? So you calculate moment of this, basically W times D. If you use scalar, right?
Yes.
It's just W times the distance, W times the distance, and you get. So basically you get something like this. So do you understand? This is if you do in scalar. Of course, if you have PD, then it will be R cross F, R cross F. But in terms of the scalar equation, then it becomes something like this. So obviously in scalar we'll resolve into x and y. So FRX is summation of fx, FRY is summation of all forces in y, and then moment is summation of all moment. Alright, that's simplification. Any question so far? Because now we want to further simplify. Okay, to further simplify, meaning sometimes they do not want in that format. They want to just, because what we have done just now is from multiple forces we become just one force and one moment at that point. And sometimes they say that's not simple enough, simplify so that there's only one force. How to do that? So the idea is basically, if you understand what we discussed just now in the example, it's basically to reverse it back. Okay, let's say you have let's say F1, F2, F3, D1, D2, D3, right? To simplify this to, for example, to point O, what do you have? Basically, you have FR and MR, let's say, right? FR will equal what from this symbol? So F1 plus F2 plus F3. Just add plus because everything is double, so it's simple. This is just for illustration. If you have XY, then you have to resolve FX, FY, and then you get the result. What about this one? So it's summation of all moments, so everything is clockwise, so it becomes F1 D1 plus F2 D2 plus F3 D3, right? Now for the simplification, meaning, okay, I don't want one force and one moment, I just want one force. So the issue is, where is the location? FR should be the same. How do you get the location? Because for example this D, what is this? D, okay, this for the R. How do you get this one? What's the concept? The effect should be the same. Meaning the moment produced by this distance should be equal to this. And when the force is here, you have moment here. When you want to have force here, this location of the force should create the same moment there. Meaning this MR should be equal to FR times ER. That's the calculate moment, right? So from here you can calculate what is DR. R divided by FR. So this is what it means by further simplification. Of course, I'm showing in 2D because in 3D then it will be a bit more complex because you have X, Y, Z, X, Y, Z. But if you understand the first thing is to understand what's going on, what we want to achieve, so that you can relate moment and distance, etc. So, and make sure you understand what the question wants, because the question say simplify this into force and couple moment at point A or point something, then they want it here. If then they say further simplify and specify the location, then they want to go until here. So that's, we will see some examples in terms of the wording they use. But do you understand the overall idea? Okay.
Yes.
All right. Okay. Okay, let's take a look at this example here. So we have 2D force system with geometry as shown. So we have three forces there. The angles are given. Find the equivalent resultant force and couple moment acting at A, and then the equivalent force is single force rotation measured from A. Do you understand the question? What does the question want? Do you notice that there's two parts of the question? Meaning the first part is find the equivalent resultant force and couple moment acting at A. What does it want? That's the first step that we do. Meaning everything must be at A now. Meaning, okay, at A what is, let's say, what is the force, what is the moment, something like that. And then they say, and then the equivalent single force and location from A. Meaning, okay, you bring something and then the location is D. So the idea is that. So the first thing that I want to make sure is, can you understand this is what the question wants from just reading something like that? Okay, make sure you understand. Because this is still in chapter 4, which is part of your midterm, right? And make sure Of course, now we are currently, as we have covered any example, it is attached to the chapter that we are covering, so it's quite easy to understand. We are still in this chapter, but in your exam, you have to understand what the question one and this is which chapter, so that you can solve, right? So make sure you understand the wordings, etc. So what to do? Let's say the first step. We want to find FR, for example, FR. Of course, I do not know where is the direction yet, but this is just to visualize what you want, right? So how to get FR? What do we do?
Plus.
You add everything. But here, how to add everything? You can just add 200, 100. So you have to do it into in terms of x and y, right? So FRX will be summation of all forces in x, right? So in this case, what do we have? This is 0, this one is? Basically it's 100, 3 over 5. That one? Plus 50.
Cost.
Is it? Sin 50. So then you get a value there, right? And FRY, summation of FY, you get 200. Okay, this is basically you get positive upwards, positive to the right and positive upwards, right? 200. For this one is minus 100 over 5. That one is plus 50 or 50. Okay, this is obviously positive, but I'm not sure about this one. This is positive anything. I'm saying it's still positive, right? Based on the number. So this is positive something, positive something. Meaning what? Meaning that FRX is like this, FRY like that, and then FR will be here, right? And then let's say theta here equal to negative 1 FRY over FRX from the triangle, right? Now that's another thing. When the question asks something like this goes back to when we calculate resultant force in chapter 2, is it? Where you have to automatically know you have to calculate for theta. Because without theta, the answer is not complete. You don't know where is the location, right? So now we have completed. Of course, we can calculate the value. You can get this one and theta, right? Any question with regard to the resultant force? You understand? What about MR? How to get MR? Right, so it's basically summation of FD basically, right? And if we take counterclockwise as positive, so we'll have for the 200 times 3 positive, right? For this one minus 100 4 over 5 this one 6 and then plus 50 cos 30 distance of 9, and then you straight away get your answer, right? In this case, I do believe it will be positive also, right? Meaning, if positive in this case, it will be counterclockwise. If my assumption is correct, I think this is bigger than this one, so I'm assuming it's positive. You can just verify. Meaning, if you're positive, then it's counterclockwise based on this one, right? So that's the first step. Meaning, you have established what is FR and MR. That answers this part, the first part. What is the equivalent resultant force and couple moment acting at A? Oh. Any question there? Anything not clear for that part? Clear ke tak clear ke? This is straightforward. This is just using what we have learned so far, right? This is what we have learned in chapter 2. This is what we have learned early on when we learn about moment about a point. Right? This is basically calculating moment about point A. Right? Okay, what about the second part? What is the equivalent single force location measured from A? Meaning, in this case, it will be something like this. If you already know the value and theta, right? You want to get what is the distance now. So how do you calculate that one? What's the concept? The concept is basically the moment produced here should be the same as moment produced here, right? So moment produced here is basically what? If you use this diagram, it will be Fr sine theta times D, right? Should be equal to Mr. So this one obviously is basically is exactly the same as Fry, right? Or if you just see Fry times D is the same thing, right? So this one you have the value, this one you have the value, you can calculate for D, then you can get the answer, right? So it's fairly straightforward if you understand what's going on. And of course it's straightforward because the question is quite straightforward, it's quite easy. And it's 2D. Any question? So is it understood? Okay, so things like this is not that difficult to understand the concept. It's just that first my concern is whether all of you understand when you read something like this, you know exactly what the question wants. Because for some, I think they feel that the sentence is quite confusing or something. What is moment A and blah blah blah, right? So make sure you are familiar with how it is expressed. What is equivalent resultant force and couple moment? Oh, this is the thing. What is equivalent single force? This is the thing. So make sure you do not lose your mark because of not understanding the question. Secondly is only I think mistakes or careless mistakes sometimes is the factor behind losing marks here, right? Alright, so if we just go through the slides, the answer will be as such. So let me FRX, FRY, we have FR and theta. Moment we also calculated counterclockwise this value, and then this is the distance here. Right? Make sure you understand, because sometimes it's okay to memorize and plug in straight away, but it depends on, because sometimes the position is quite tricky if the structure is in a different format. But anyway, as long as you understand what's going on, you should be fine here, right? Any question for this one? Okay. Okay, let's try this one. This is 3D, but it still can easily be solved with scalar because everything is vertical. Right? So it's still easy. That it doesn't have alpha, beta, gamma, etc. yet. So the question here is, we have the slab there, and then we have three parallel forces. Find the equivalent resultant force and couple moment at origin O, and also find the location xy of the single equivalent resultant force. So you can detect the two questions and what the question wants. This is exactly basically at point O. What is, let's say, force and let's say something like this, moment Fr and Mr, for example, right? And then the second part is, oh, my mark is already, Fr is somewhere there. Then what is the coordinate x, y? So that's basically it, right? Alright. So from the previous example, you already understand the concept. So how to get FR? Because in this question, it should be very, very straightforward.
Minus.
Okay, if you want to use, okay, can you use scatter here? Or you want to use vector? Okay, if you use vector, what do you have? FR. Everything will be in K, right? So this one will be 100 K positive, this one will be minus 500 K, that one will be minus 100 K, we'll get minus 800 K, right? So scalar, of course, you can do, but normally you have to specify are you taking upward or downwards as possible. But in this case, it's still easy because you don't have X, Y, Z. What about MR? Do you think it's easier to do scalar or vector? Vector. So if you want to use vector, it's basically just summation of R cross F for each one, right? So for this 100, what is R cross F? What is R? If I'm skipping step, right? It's basically summation of R cross F. So if I straight away put in terms of the matrix, what will be R for this 100? 300. 300, right? And then 0, 100, right? Then plus we have let's do the 400 first. What's the R for that one?
0, 400, 0, 4,
0, 4, 0,
0,
400.
minus 100, right? And then for the 500 meter, K, yeah? 400. 4. What is the X? 4, 1, 4, 0, 4, 0. And then 0, 0, minus 500. Right? And the rest is just calculation. In this case, it's quite easy because there's a lot of 0 there. So you have, I think you know what to do next, right? And then for this one, you get something IJK. Of course, for I is 0. For J, you have something. For K, you get 0 also. Similarly here, so, and then you have it to our IJK. So that will solve the first part, which means this one. You get what is FR and what is MR. Any questions so far? Of course, you have to try the calculation mathematically. But I think I'm not spending the time there because I assume you know already what to do, right? Any questions so far up to this point? How to do this one? The next one? Because in 2D it's still easy to visualize the distance, right? Or how do you deal with this one? If you already have this MR here, right? So it's not here. Just 31 seconds. We have IJK. Because here we have, okay, for I 0, right? 0. For J, 300. For K, 0. This one for I, minus 1600. Right? Minus J, 0, K, 0. This one I, minus 2000, minus J here. Okay. Is it 2000 minus? What do you do if you do like that? You get minus 2000, right? And then plus K, 0. Right? So in the end, for I, you have minus 161 minus 2000, it becomes minus 3600I. And then for J, minus 300, minus become positive. So plus 1700 J, and then 000. Is this correct? Make sure you take care of, because this is negative, right? What is this? This is negative, right? And then anything need to become positive. 2000 minus 300 becomes 1700. Alright. Any question? Any problem? Which one? Yeah. Negative, yeah. Negative 300. This 0. This become minus, become positive 200 and 2000. It becomes minus 300 plus 2000. From here. Which one? Why is minus? This is going back. If you want to use that method, it's positive I minus J plus K, right? If you change that one, then the whole thing will come wrong. Because if you want to memorize, because I think I showed you three ways to solve this matrix, right? If you want to use that method, then you have to just either you understand why is it positive, negative, positive, or you just memorize. So please refer to those notes when we cover cross product. Okay, this is still this one. MR becomes this one, right? How to get to this one? We have not yet finished here. Okay, how do you calculate moment here? Because the idea is moment here should be the maximum moment there, right? How do you calculate it? What is R? If you say this is coordinate xy, so it will be I, J, K, what do you have here? X, Y, 0. What is FR just now? 0, 0 minus 100. So if you solve this one, I minus 800 Y, plus minus J, minus 800 X, and then plus K, 0, right? So in the end, this should equal to this one. So you can get the equation, right? So for I should be equal to I, meaning minus 800 Y equal to minus 3600. So Y equal to 3600 over 800. And then for J here, should equal to this one. So this one is negative, negative, become positive. 800x should equal to 170. So x equal to 1700 over 800. And then you calculate the answer. So as long as you understand the idea, so you can just, okay, the concept is this moment equal to this moment. And you know how to calculate moment already. R cos F. What is R? In this case, x, y, because the coordinate is x, y. F, we already established. Okay? Is it okay? So so from my perspective, it becomes easy if you understand what should be the case, right? Or the moment should be the moment, then I just calculate moment here, whatever happened here, I just equate there, right? Because if you see the slide or you see the solution, it appears something like an equation. And some students memorize the equation, then that can be very dangerous. For example, if you see here, it appears as if it's an equation. But this equation does not necessarily become true. Why is this negative and R divided by this one? Why is it positive? This positive and negative is based on the understanding of the notation. So if you blindly memorize this one, you will get it wrong in the exam, right? So make sure you don't do that. You have to understand. This one is using scalar, right? Why is this negative? Do you understand why is this negative? Because for about x-axis, if you take, so that's the discussion of clockwise, counterclockwise. So you have to be able to memorize, visualize, right? The FR is going down, so then it's clockwise, so that's negative, blah blah blah. So we don't have the time to actually show how to. You can calculate this one using scalar also, but does involve a lot of clockwise, counterclockwise, clockwise, counterclockwise. Normally it's easier to use cross product as we have done just now, because positive and negative automatically, this is automatic. You don't have to think about, unless you don't memorize this, you should already now know positive, negative, positive, right? And this negative, then plug in, you can get it correct. Alright, so we have only 3 minutes left. I think I'll just, because I returned your quiz. I only managed to, this is not, where's the now, so I only managed to. Oh yeah, I have. Okay, we have to discuss something actually. First, we can take a quiz before you leave. Everyone have signed? Right. Now, on Thursday. Okay, attention. On Thursday, unfortunately, I have. Sunday I was called to attend a meeting for the full day, so I cannot be here on Thursday. However, we still have a lot to cover in chapter 4. And what is the week number? 5. This is only 5, isn't it? Now, so I'm not sure how to place by any chance, because I'm thinking, I'm not sure if will this be conducive or not. If I record the session today and then and on the time of lecture on Thursday you have, then it's on you to just view the recording of the session. Is that something that is okay for you, or you will not understand it? My honest question. Faham soalan tak? Okay ke tak? Tak kisah. No, because if I want to do that, I will set a time to do that recording. Meaning I will do it from 5 to 6 today, for example, PM. So that it will be about 1 hour, and then you have to do it on Thursday on your own, or on your own time. Right. If I want to do that, I think it's open, because otherwise I think if I'm working on my own, it's not that natural way, right? Anyone actually free and want to be in that session? For today, 5 to 6 PM. No, today. Actually today, bukan apa lagi.
Is it new stuff or like?
New stuff. Yeah, we continue new material. Otherwise, we have to find some. We still have to find some replacement time on any other time. So, which week do you prefer?
Friday.
I think the challenge is to get, because why I'm thinking in that route, because to get a time where everyone agrees, we try to discuss before, it's quite impossible. So, any decision? Any? Otherwise, I'll just decide and I'll proceed. No? Okay, no response. Anyway, so with that, I think I'll just so I'll just do the recording for this session later today, 5 to 6 PM. For those who don't prefer to watch a video, and actually free on that time. So on 5 just be near my office and we'll find a class there and we'll just take the session. So you will be, meaning your class is settled on the spot. For those who are not available or just want to do it later, you can just view it when I upload it before Tuesday. Is it clear?
Yeah.
Alright, so with that we have to end the session here. Assalamualaikum warahmatullahi wabarakatuh.